Okay, we're back here with video number 2, and we are looking at the topics for today for 13 differences between the tabular model and Olap in SQL Server 2012. Now, first of all, just to clarify the versions here, the tabular model, the new way of creating analytic databases, is available only in SQL Server 2012. The tabular model does not exist in prior models. This is new in the SQL Server product. The Olap capability, everything I'm talking about here today, you could do in 2008 R2 and 2008, and most of what I'm talking about here today you could do in 2005. Microsoft did add a few features to Analysis Services Olap from 2005 to 2008, but most of what I'm covering here today on the Olap side would still apply back in 2005. So just want to clarify the other versions. All right, going to take a look at a history of the two methodologies. Now, I've actually got here 1, 2, 3, 4, 5 slides that deal with the history. I am not going to go through and read all of these bullet point by bullet point. You can obviously pull down the slide deck from my site. Obviously, this is up on the screen here, so you can pause and read it yourself. So I'm certainly not going to go through all of the bullet points on here. The key points to remember is that Microsoft for years has had analytic database capability, the ability to create databases so that end users can slice and dice data. They can get trends out of the data. They can get a certain amount of information out of the data without needing to run to a developer every 5 minutes to write queries. This is something that Microsoft has had at varying stages going back many years. They actually had an Olap Services product back in the late 90s, and then released Analysis Services in SQL Server 2000. Now, by today's standards, what was an Analysis Services 2000 was pretty weak at the time. My personal opinion is that Microsoft hit the radar. They hit the big time with creating analytic databases in Analysis Services 2005. Microsoft put so much functionality into 2005 that was really where Analysis Services and Olap grew up as a product. Now, there was an enhanced version in 2008. They added some MDX enhancements. They added some data mining enhancements, but really most of what I'm going to cover here today on the Olap side does apply to 2005. So by the time SQL Server 2005 and even 2008 came around, Olap developers had great tools to build multi-dimensional Olap cubes to give end users more advanced analytic capabilities across historical data. So, now, I love Olap. I think Analysis Services is a great product. I don't think it's perfect. I think there's some areas that I wish Microsoft would have paid some attention to over the years, but no product can be perfect. But overall, I've always liked Olap. But there have been criticisms of Olap. Some felt that it was too difficult to learn. Well, as an instructor, I can understand that, but the products that produce great results usually do have some kind of a learning curve. The corresponding programming language, MDX, is certainly not something you learn overnight, and it's a different paradigm than relational databases. Sometimes you almost have to forget, you almost have to have selective amnesia when you move from relational databases to Olap databases, because some of the rules we have for normalization in OLTP transaction databases, well, those rules change when you get into building data warehouses and data marts and ultimately Olap cubes. So this has always been a great product, but the learning curve has been considerable. Well, what happened is along the way, the market started to see other tools that allowed developers and power users to build analytic databases with less complexity or less perceived complexity. And one product that has almost, well, not almost, it has achieved brand recognition is QlikView. QlikView is a very good tool. I like it a lot. I think it's a great tool. I think there's some things that QlikView does that better than what the Microsoft platform does, and I also think there's some areas where the Microsoft platform does things much better than QlikView. That's usually the way it goes when you compare one product to the other. But when QlikView came out, you had a product that allowed developers or power users to build analytic databases so people could slice and dice data without necessarily going through some of the complexities of Olap. Now, Microsoft did something very interesting in the spring of 2010. They introduced an Excel add-in as part of SQL Server 2008 R2 called Powerpivot. Now, Powerpivot, I'm not going to read through all these bullet points here, but Powerpivot essentially allowed end users to utilize Excel, point to a data mart or some other relational database, or create some data mashup, and essentially build under the hood the equivalent of a star schema analytic cube using a capability called Vertipack, which is now referred to as XVelocity. It's a technology that creates a column star index that compresses data down to about a factor of 8 to 1 or even greater, and allows people to query 20, 30, 40 million rows or more very, very quickly. Now, this was not a full-blown Olap solution, but it opened the door for business users to take segments of information within a company and build analytic star schema cubes using nothing more than Excel. Now, why is that relevant to the tabular model? Well, I'll get to that in a minute. But by the mid-2010, there were two ways to create analytic databases. For the big projects, use analysis services, or some people would say MOLAP. For more departmental or personal BI solutions, you could use Powerpivot and utilize Excel and point to some data warehouse or some data mart. Well, in SQL Server 2012, so now we come up to the present, Microsoft took certain aspects of Powerpivot, enhanced it, and fit it into SQL Server Analysis Services as a separate way of creating analytic databases. So you still have multidimensional Olap. That was largely unchanged from 2008. They actually added a few small enhancements, but for the most part, Analysis Service 2012 is about the proverbial 98-99% of what it was in 2008. But there's now this new tabular model we're going to take a look at today. It's not necessarily as powerful as multidimensional Olap, but still might be sufficient for many corporate BI solutions. You can create an analytic type database using SQL Server data tools and then access them in things like reporting services or performance point services, just like you would with an Olap database. One of the things that's going to surprise some people is that with this new tabular model, you might go about building it in a different way, but then when you go to consume it using something like performance point services or reporting services or even Excel, you're going to wind up working with it in those client tools much in the same way as you did an Olap database. Now, some people like to use this new tabular model for prototyping for what will eventually become an Olap multidimensional database. So again, I'm going to focus on these two areas here. Now, sort of incidental to this, Microsoft released an updated version of Powerpivot, and so now it's Powerpivot 2.0 within SQL Server 2012. And this was a welcome news. My opinion, going back to Powerpivot 1.0, which is part of 2008 R2, this was a promise of a product, but there were a lot of quirks in it. Microsoft sketched some very, very big broad strokes with this. It worked, but it didn't work well. There were quirks with it. There were times where Excel would lock up or just shut down. There were reported instances where Powerpivot models you would create would get corrupted and you'd have to rebuild them. So Powerpivot 1, like a lot of 1.0 products, had some work to do to really make it ready for prime time. Well, they did that in Powerpivot 2.0. Powerpivot 2.0 is now a prime-time player for the departmental or the personal BI area. I'm not going to talk about this as such here as a product. It's a separate product. I'm going to focus more on multidimensional Olap versus the tabular models. So that's where we are today. Now, it is likely, I don't have a crystal ball, I can't predict with 100% certainty, but it is likely that in the next release of SQL Server, whether it's a year and a half from now, 2 years from now, 2.5 years from now, whenever that's going to be, that the tabular model will have more enhancements to it. It, in my opinion, doesn't have some of the necessary features that you find in Olap, but I have a feeling that will probably change in the next release. Now, getting started, how do we build things using both multidimensional Olap and tabular? Well, you'll actually find that they are really pretty similar. The screens might look a little bit different, but getting started is very similar on both sides. Now with Olap, you can use whatever is the most recent version of BIDS or SQL Server data tools that you have. Remember I said that everything I'm covering here today goes back to SQL Server 2008 and even to a large degree 2005. So you create a new SSAS project, you define a data source, you create a data source view, and you build a cube definition. Now, I went through that in my last video. I'm not going to reinvent the wheel or go through steps again. So that part is pretty basic, and then the tabular side is pretty similar. Now, the one thing I will say that's different on the Olap side, and we'll get into this a little bit later, on the Olap side there's a separate dimension editor for customizing dimension attribute properties and customizing dimension behavior. There's separate editors for that. Over on the tabular side, they don't really have separate editors in the same way that you're used to in Olap. Any customization of dimensions is actually done within the model view itself, and I'm going to pull that up in just a minute. Now, you still go about building a tabular project using SQL Server Data Tools 2010 or 2012 in a very similar way. You build a project, you point to a data source, you build a model, you build the relationships. But one of the biggest differences is there's no separate dimension editor. As I said, the dimension behavior that you set is actually embedded in the model. Now, when I get into one of the next bullet points, I'm actually going to pull up SQL Server Data Tools on both sides and illustrate this. But the getting started is, I really wouldn't say they are tremendously different. Obviously, in Visual Studio, you're going to create a new project, and you've got the option in Analysis Services to either build a regular multi-dimensional Olap project. They don't call it Olap, they call it multi-dimensional. Or you can build an Analysis Services tabular model. And in both cases, you point to a data source, you point to which tables you want to pull in, and then you go from there. So not a tremendous amount of difference between the two. Obviously, the differences get bigger once we drill into some of the bigger details. Now, here is where we start to see some pretty big relationship, big differences in the two, and that's where we get into the advanced fact dimension relationships. Let me come over here to SQL Management Studio, and I'm going to pull up in Adventureworks in their little data mart here, Adventureworks DW. They call it a data warehouse. It's more like a data mart. I've got some views in here, things like VFACT Internet Sales Summary, VFACT Reseller Sales Summary, VFACT Reseller Sales Quota. These are fact tables. These are actually views built on top of the Adventureworks fact tables for the different sales channels. And I've got some basic flattened denormalized dimensions here for product and for date and for promotion and geography and so forth. Now, in some instances, the relationships are direct. For instance, if I take a look at Reseller Sales Summary, if I right-click and select the top 1,000 rows here, well, I've got in here a product key, I've got a reseller key, I've got an employee key, and I've got a promotion key. And I've got corresponding dimensions here for product and for reseller, and obviously that's very basic stuff. Shouldn't have to go into the specifics of that. Well, both the tabular model and the multidimensional model can handle them fine without any difficulty. But let's start talking about where we have relationships that are not so simple. I'm actually going to start with role-playing relationships because this is one that I run into with several clients. We have in here in fact Reseller Sales Summary, we have an order date key, a due date key, and a ship date key, representing the three different views, three different ways that we take a look at that particular order transaction. So we might want to track order dollars by when the liability was booked, the order date, when the order was due, when it was shipped, and so forth. Obviously, you might have a lag of a couple of days or even a week, and that lag might be critical in taking a look at dollars rolled up across those three views of things. Now, I've had some clients, as a matter of fact, I had one in the last year, that had 6 or 7 different views of dates. It was actually in a manufacturing environment where you had a work in progress date, you had a date for this, a date for that, a ship date, a cut date, etc., etc. And people wanted to look at production volumes rolled up by plant, by shop, by division, by whatever, according to certain months based upon those dates. So it's not uncommon to have 5 or 6 or even more dates. And as I said, my one client had, it was either 7 or 8 of them, something like that. within one fact table. Well, here's where the two models differ. In analysis services, using Olap, if I have a primary key foreign key relationship, if I have some kind of model relationship between these three dates and the date key in my date dimension, if I have a relationship there of some type, so here's my date, let me actually, meant to just pull the rows here. If I have a relationship between the date key here and then the three different dates in order date, due date, ship date in this particular fact table, I'm going to open up the full-blown version of Adventureworks on the Olap side, the full-blown Adventureworks demo, and show how Olap handles it. Because this is pretty important as far as what Olap provides out of the box. So just wait for this to load. I probably should have loaded before I started. And I'm going to go specifically in the cube, in the Adventureworks cube, to the dimension usage area. And let's take a look at reseller sales here. By order date, the default date here is order date, by ship date, and by delivery date. What Analysis Services does, if the relationships have been set in the data source view, or you can build them in here yourself, you can have three views of that date dimension. This is provided pretty much out of the box. So if I take a look at the intersection point for reseller sales with ship date, well, it's a direct relationship, and it's taking the date key from dim date and tying it to the ship date key over in fact, reseller sales. And it's using the other date keys for order date and for delivery date. This is provided out of the box. Now, Analysis Services Olap is not creating three copies of the date dimension. It's building three date views. So what that means is that the end user can roll up sales by any date attribute associated with the date dimension according to these three views. So just as an example, if I go over here to the browser, I believe I've deployed this ahead of time. If I go over here to the browser and take a look at reseller sales by those three dates, from the measures I'll pull in from reseller sales, I'll just pull in reseller sales amount. And notice how down further in the date dimensions I've got order date, again they just call it date, delivery date, and further down ship date. So maybe I want to take a look at the reseller sales broken out by fiscal year as a very basic example. So any lag going on between order date and ship date is reflected in these numbers. So we don't have to do very much to get that functionality. We just have to simply make sure that the relationships are there. That's the good news. Over in the tabular model, not quite as simple. I'm going to come over here to a second copy of Visual Studio, and I'm going to open ahead of time. I have a demo of Adventureworks that I'm going to pull up that I built with a tabular model. And wait for this to load. And I have to put in my default server name here. 1 second. Host SQL 2012 Tabular, I believe that's what I called it. And oh, that's interesting. I pointed to the wrong project. Oh, you know what? I pointed to the wrong folder. That was my fault. This is one I meant to point to. So let's see if we have better luck in this one. That's one of the dangers of having so many demo projects, is once in a blue moon you point to the wrong one. Alright, so I'm pulling up the Adventureworks tabular model, the equivalent demo, and in the model view, if I could take a look at the model view here and actually look at the data diagram, I will see that just like over in the Olap project, I've got reseller sales tied to the date dimension. Now, it's a little bit difficult to tell in this diagram, but trust me when I tell you that the three dates here for due date, order date, ship date, so forth, the three keys here, foreign keys, are tied to the date dimension over here. However, that doesn't mean that the end user can roll up the sales amount by any of those three views. The tabular model doesn't provide that out of the box. It actually is only going to use the first relationship. It's not going to let you easily roll up the sales amount by any of the three dates. Here's what you have to do. Here's where you'll often hear people say that where the model in the model relationship capabilities of the tabular model fall short, you write DAX code, and here's one example. I'm actually going to go back in the model and view the data. And under reseller sales, here's how we supplement what's missing in the relationship capability. Notice how I've got sum of sales amount, sum of ship sales amount, sum of order sales amount, sum of due sales amount. We have to actually write DAX code. We have to actually implement measures for every measure where we want to have a role-playing relationship. Now if we take a look at the DAX code here, essentially the sum of the sales amount on the reseller side according to the due date, we essentially issue a calculate function in DAX where we sum the core sales amount measure according to the relationship. We use a DAX function called use relationship between the date key within the date dimension and the corresponding due date key over on the reseller sales side. Now once you learn how to do this, then it's not the end of the world, but the point is that you've got to implement separate measures for what you would have otherwise done with different views of the date dimension over on the Olap side. So this works, but I can't really say that it works as elegantly, because if you have 10 measures, you're going to have to explode this out into 30 different possibilities, 3 for each measure. Well, that's a little unwieldy, but in some environments that is actually going to be the case. Now some people might implement this differently by building different models for each date dimension. They build one model for order date, one for due date, and so on. Well, you can do that. Again, I don't think that's a particularly elegant solution. So this is definitely one where the traditional Olap side, in my opinion, works better. You really shouldn't need to explode out different versions of calculations to utilize the different relationships according to that particular role. It's something that the model should be able to handle, but the tabular model doesn't. So that's one instance where the role-playing dimension works much better over the analysis services side. Now there's another type of relationship that people run into from time to time, and it's a many-to-many bridge relationship. Examples of this. One example is in Adventureworks where you have sales that you might want to associate with different currencies. Well, sales doesn't slice directly to currency. You might need a separate bridge table that has the currencies by country and by date, since obviously today a dollar might be so much to the Canadian dollar, and tomorrow it might be a little bit different, and the next day it might be different again. So if you want to relate fact sales like fact dollars to the currency dimension, you got to go through a bridge table. So this is what we refer to as a many-to-many relationship. Well, again, Olap handles this actually very well. It does it through a couple of properties, but it handles it very well. In the tabular model, you've got to write some code. Now, again, some people might say, well, okay, so you've got to write code. We're developers. We have, that's what we do for a living, and that's certainly true. But what we're talking about here is what capabilities are built into the core product and where we have to supplement them with DAX code. So if you're building a tabular project, these are things that you need to be aware of if you're accustomed to these working in the Olap side. For instance, if I come over here to the full-blown Adventureworks product, if I want to take a look at internet sales by currency, let me go to the intersection point here. If I want to take a look at internet sales by a destination currency, it's done through an exchange rate table, where that exchange rate table is out here to the right, and that exchange rate table has one other dimension in common. That's the date dimension. There's always a pattern with bridge table relationships. If we want to slice internet sales by, in this case, currency, even though sales isn't tied directly to currency, and we need to bounce off of a separate fact table to get the rates for that day for that currency, that exchange rate table has to be tied to the fact table as a many-to-many relationship, where that fact table has one other dimension in common, and that's the date dimension. Now, when you do that, in the cube structure here, when I take a look at internet sales and at the actual internet sales amount, there's actually under the hood a measure expression. If I can pull this out here, there's actually a measure expression under the hood that divides the internet sales by the average rate from that exchange rate table. So it's actually doing the joining, for lack of a better word, and the calculation that factors in the average rate for that day and for that currency. It's doing it on the fly for us. Now, in addition, come back here to the relationship between the measure group and destination currency. There is also, because we might have default currencies, there is a default that we can set in a property called direct slice. Because if we know that we're normally going to be looking at things by the US dollar, and we really don't want it to go through all of those gyrations, we don't want it to do a lookup to divide by 1 for the currency rate because we know that we're already looking at the US dollar, we can set a default property in here for direct slice for the US dollar. So there are things that we can do with the many-to-many bridge table relationship under the hood to implement this functionality right out of the box. Well, over on the tabular side, the editor does not handle, the relationship editor does not handle those bridge relationships at all. Now, I'm going to actually pull up a different project here on the tabular side to illustrate bridge table relationships. This is one that I've used as a demo for years. And hopefully I'm pulling up the right one here. No, that was a report project. All right, I'm pulling up the wrong demos here. Yeah, here it is. And, okay, I actually realized that is actually on a separate disk. So I'm actually going to stop this video right now because I need to, or I'll tell you, I'm going to pause it here because I need to pull up a project that's on a separate disk so I can show a bridge table relationship in Tabular. So I'm actually going to pause the video here for just a second. Okay, I resumed here. Actually, I had to, the project I needed to open was actually on another drive, so I needed to bring it onto this laptop here. So here's an example of a tabular model that needs to implement a many-to-many bridge table relationship. Now, I actually use a slightly simpler one for demo purposes, and this is actually based upon something I had to do for a client a long time ago. Let's say that we have a sales table of sales by book. So we got a table called Fact Book Sales with sales by book and by date and customer and so forth. Well, we might also have a separate author table. Now, I've just got dummy author names in here. Now, the thing about books and about authors is that one book can be written by many authors, and an author can write many books. And I know that from personal experience, I wrote one book where I contributed about 80% of it, and another book where I contributed maybe at the most 10% of it. Well, in that scenario, let's take the book that sold where I wrote 10% of it. And let's say the book sold $100,000. Well, my share on the basis of determining royalty is not $100,000. It's 10% of the $100,000. So we need a measure that is going to take the sales dollars and multiply it by the author's share. Well, in the Olap model, over in Analysis Services Olap, that can be handled through a bridge table and through the built-in relationship. So the work is actually not that difficult. Well, on the tabular side, it's a different story. Now I've got a separate bridge table here called Books to Authors, where we've got every book, the author, and then the author share. Now, in many instances, the author share is 1 because that's the only author in the book. There are, I think, maybe 1 or 2 records in here, I'm not sure where they are, where the author share is something other than 1. Yeah, a couple down here at the bottom where it's like 0.2, 0.4, and so on, because the one of the authors only contributed a portion of the book. Well, in this case, once again, if we want to have a calculation of author dollars, we need a special measure for it, because the built-in relationship capabilities in the tabular model don't support this kind of relationship directly, whereas over on the Olap side it does. So just to illustrate this, if I were to actually take a look at this data in Excel right now, and by the way, sort of incidental to all this, over in the tabular model there's a nice way that we can look at data immediately using Excel. So I'm going to click on the Analyze in Excel option and view the data using the current Windows user. It actually pops up Excel and sets a connection string right away to a temporary deployed version of that tabular database. Pretty neat. Alright, well, I'm going to look at the sum of sales dollars by author. So I'll come down to the author and I'll break it out by the author full name. Well, I've got everybody having the same sales dollars, so obviously the data is not slicing correctly. That's because the tabular model does not support this kind of relationship. What we need is a calculation, a special DAX calculation, so a repeated theme here. We need to write DAX calculations to supplement what the tabular model doesn't do out of the box. Well, back up in fact sales, I had a calculation called author dollars. We'll take a look at that. So author 5, it turns out he wrote a couple of books, or at least one book, maybe more than one, and his total author dollars on which to determine royalty is $89.61. So how do we implement that? Well, let me come back over to the project, and I'll come over to that factbook sales table. There's a measure in here called author dollars. Now, another thing about this interface is that there's no one single area for these calculations. They're sort of spread across the fact tables here. But if we take a look at the calculation for author dollars, well, we are essentially going to sum the sales dollars from factbook sales and multiply it by the corresponding author share from books to authors using the dimension in between, the book dimension, or in this case the book price dimension, because I've got it more normalized, multiple prices per book, in order to come up with the author dollars. This is what the Olap model will do for us out of the box. It'll actually sum the dollars and let us multiply it directly by the author share from the bridge table. Here we have to actually sum utilizing the dimension in between. So we have to implement this in a DAX calculation. We don't get built-in support for it. Now again, is this the end of the world? No. Although I do have to say it took me actually several days worth of research to figure out how to do this. Now this was when the tabular model was just out, so there wasn't as much in the way of blogs or book information as there is right now. If you go and look up many-to-many bridge table calculations for the tabular model, if you do a look up now on the web, you'll see many examples. When I was trying to do this, there weren't as many around. So at the end of the day, you can still get the same impact to the end user, although it does require a little bit more code. So coming back here to my slide deck, and let me get back to the slide that I was on. We need to build. Let me minimize this. We need to build DAX extensions for those areas where the relationship capability in the model is just simply not nearly as strong. This is just a fact of life with DAX. So where you have complex snowflake relationships, where you have role-playing relationships, where you have bridge table relationships, be prepared to write some code to in order to implement the necessary calculations. I can understand needing to write some code for the many-to-many. That's a more complicated one. I think the one that personally I hope that they really address is the role-playing relationships, because I'm personally not crazy about having to explode out separate calculations for every measure for every possible date view. To me, that's something that needs to be addressed. So again, this is something that you want to at least be aware of if you're going to build tabular relationships. Now, the fourth point here, and I'm not going to spend a lot of time on this only because I'm actually going to be having separate shows to talk about this in detail. But the last point is a segue to this next topic of the different programming languages. MDX versus, and actually I just now realized my slide deck up here is wrong. That should actually be MDX versus Tabular. It's MDX versus Olap. It's actually not true. Usually I always find something here. It's MDX versus DAX. So we'll come back here. Now Olap uses MDX, and MDX is a language that's generally more difficult than T-SQL. It's a language that picks up the context from fact dimension usage relationships. So when you take a look at DAX code, you have to keep in mind that it's going to be evaluated based upon a context of how people are slicing data at runtime. Now, next week on the BDBI radio schedule, next week I'm actually going to be going through 13 examples of using MDX code with Olap applications. So I don't want to get buried in too many specifics of MDX here. Next week, I'm actually going to take a look at 13 examples of using MDX in different Olap applications, like in reporting services, in performance point services, etc. And as I said, the language is not the easiest in the world to learn. Definitely requires quite a bit of effort. Now, Tabular model uses DAX, and actually the examples that I showed earlier, where I was calculating based upon a context, in this case the relationship involving the reseller sales to the date key and the date dimension. That's an example of a DAX formula. Now, some DAX formulas are very simple, others are complicated, and others are very complicated. There's been some communication in certain blogs and magazine articles that DAX is somehow easier than MDX. I strongly disagree with that statement. I emphatically disagree with it. I'm not criticizing DAX. DAX is a very powerful language. I think it is roughly about the same level of difficulty as MDX. It is simply different. There is some overlap with DAX, between DAX and MDX. You will see the same or similar functions, but then the usage gets to be different. One of the difficulties with DAX is sometimes the syntax, as far as the placement of the brackets and the placement of single quotes, can take a little while to get used to, but then again you have similar issues with some of the MDX operators. Now, a couple weeks from now I'm going to devote a program to just specific DAX formulas. So I don't want to try to turn this into a training session on MDX or DAX. That's a topic for another show. So next week I'm going to talk about MDX, and then a couple weeks now I'm going to talk about DAX. Now, what is interesting, and I'll get to this point in detail later, but I'll at least bring it up now. What is really interesting is if we build a tabular model and we deploy it and we use something like reporting services to go against it, you would think that reporting services would generate, if we bring in a measure and bring in a dimension, that it would build DAX code behind the scenes. In the same way that if we pointed to an Olap cube and brought in a fact and a measure and a dimension, it would generate MDX code behind the scenes. Well, believe it or not, if you build a tabular model, deploy it, and then build a reporting services report against it, reporting services behind the scenes generates MDX. I'll explain why a little bit later. So we'll see that in a later bullet point here in this presentation. All right, I've actually been going on for close to 30 minutes here, probably another good time to take a break. So next I'm going to talk a little bit more about calculations and KPIs. So I'm going to stop the video here, and then we'll pick this up in the next one.